5-day LeetCode coding challenge, and today we are going to solve our next problem statement, Dota2 Senate. So let's start. In the world of Dota2, there are two parties, the Radiant and the Dire. The Dota2 Senate consists of senator coming from two parties. Now the senator want to decide on a change in the Dota2 game. The voting for this change is a round-based procedure. In each round, each senator can exercise one of the two rights. The first right is a senator can make another senator lose all his right in this and all the following round. The second right is if the senator found the senator who still have the right to vote are all from the same party, he can announce the victory and decide on the change in the game. Given a string senate representing each senator party belonging, the character R and D represent the Radiant party and the Dire party. Then if there are n senators, the size of the given string will be n. The round-based procedure starts from the first senator to the last senator in the given order. The procedure will during the procedure. Suppose every senator is smart enough and will play the best strategy for his own party, predict which party will finally announce the victory and change the Dota2 game. The output should be Radiant or Dire. We have given a Senate list and all the Senate belong to either Radiant party or the Dire party. And every Senate have the two rights. The first right is ban another Senate from voting, or we can say eliminate another Senate. And second right is declare victory. But the condition to declare victory is all remaining Senate having rights belong to same party. Now let's understand the test case. We have given the Senate list RD. Now the process happens from left to right. So first round, if our first Senate came R, he cannot exercise the second right because there exists another Senate from the Dire party that still have the right, but he can exercise the first right. He can ban another Senate. So the first Senate can ban the second Senate. So first round, R first Senate bans second Senate. Right now, if the voting reaches to D the second Senate do not have any right, so he is skipped. Now for second round, now the first Senate can exercise their second right, which is all the remaining Senate are belong from the same party. Remaining Senate having the right. So second Senate do not have any right, and there is only one Senate left that have the right belonging to the Radiant party. So now he can exercise his second power, and now we can say first Senate declare victory. So the winner is Radiant party. Similarly for second case, first round, first Senate bans second Senate, or first Radiant Senate bans our second Dire Senate. Now second is skipped because he is already banned, and the third Senate bans our first Senate. Bans first Senate. Now at the second round, first is already banned, second is already banned. Now only remaining Senate is D, and now he can exercise his second right. So now declare victory, and the winner is Dire party. So we need to apply this right for every Senate and need to find which party wins the whole procedure. So let's let's discuss how we can solve this problem statement. So we have created a Senate list triple D RDR, right? And the size of this string is 6. So suppose the index is starting from 0. So the size is 6, n minus 1, 6. Now we have created a 2 queue, one for radiant and another for dire. And in this queue, we are storing the index of the Senate. So in the radiant Senate lies at the 0 index, 1, 2, 3, 4th index and 6th index. So 0, 4 and 6. Similarly, the dire Senate exists in the first index, second index, third index and 5th index. So we have created a queue, stored all the indexes of our radiant and dire Senate. Now, if the fight happens, it will always happen from left to right. So first fight happen between the first radiant Senate and the second radiant Senate, and whoever Senate comes first, he will ban the another Senate. So first Senate is at the 0 index and the second dire Senate is at the 1 index. So obviously the first radiant Senate will ban the dire Senate. So whatever index is less, he eliminate the another Senate. So for first 0 is less than 1. So radiant bans the dire or eliminate the dire Senate. And then what we have to do, we need to move our radiant Senate to the back of the queue and increase the n plus 1 and do the increment of n plus 1. So our n is initialized by 6, and when we move our radiant Senate to the last position, it goes n plus 1. So now the new position is 7. Now this 4 and 6 goes forward, 4 and 6, and 0 move to the backward and the new index is 7. Similarly, the this one Senate of dire is got eliminated, and he do not have any position in the queue because he has lost all his right. So he is eliminated. So now this queue move forward 2, 3, 5. Now 2 is less than 4. So now radiant Senate is kicked out and 2 moves to the backward. So we do n plus 1. Our last n value was 7, and when we do the n plus 1, it will become 8. So now move it forward, 6 and 7, and 2 goes to the backward, n plus 1, so it becomes 8. And 2 and 3 and 5 moves forward. Now 6 and 3, again the dire Senate wins, and he kicked out the radiant Senate, and he moved to the backward, and we do n plus 1. So our new queue is 5 and 8. And when we do the n plus 1, it becomes 9. And our 6 is kicked out, 7. Now again, dire win, and he kicked out the last radiant out. And he moved to the backward. So now our queue is 8, 9, and he moved backward, n plus 1, 10. But our radiant is kicked out. Now our queue is empty. So whenever either our radiant queue or dire queue is empty, it means somebody has win the procedure. So now radiant queue is empty and dire group is wins. So we say ki dire wins. So this is the approach we need to do. And let's jump to the coding part to implement this solution. Let's delete this. We can define 2 queue. One is for the dire, one is for the radiant. The new, so our first queue and our second queue, integer dire equal to new linked list of those. So now our radiant and dire queue is done. Now we have to add the index of the radiant and dire Senate. So we iterate over our string I Senate dot length I plus plus if our Senate dot character at I is equal to radiant, if it belong to radiant group, add to the radiant queue, radiant dot add I, else we add it to the dire queue. So dire dot add I. Now we have added the radiant and the dire synod in the queue. Now let's store the length of synod in the end variable. Now we have to do the second step. We have done the first step, storing all the indexes in the queue. Now we have to make the fight between the radiant and the dire queue and keep on moving whoever wins, keep it moving to the back of the queue. So while radiant queue is why radiant queue is not so we need to leave the while loop as soon as one of the queue get empty. So dire dot is empty. If radiant win, it means the index of radiant is less than the dire index. So if the radiant synod comes first, we eliminate the dire synod and move our radiant to the back. So now our radiant win, so we add our radiant synod to the back. What we need to do n plus plus. Basically, if radiant win, we moving it to the we are adding radiant to the queue, but increasing the value n plus plus, and we will eliminate the 0 and the 1. And if the dire width added to the queue, now remove the existing value from the queue. Radiant.form dire.pop. So for the first case, we remove the 0 and 1 both from the queue. But if the radiant win, we add the n plus 1 to the end of the queue. So this is what we have done. And same for the radiant and same for the dire. Now if the radiant queue is empty, it means the dire wins. Else radiant wins. Yeah, so we are done. Let's run the test case. It is not pop, it is remove. It is add, sorry. It is add and it is remove. Let's run it now. So our test case is working. Let's submit our solution. Third solution is also working. Thanks for joining the session. Let's meet tomorrow.